Bridge deterioration has reached the point of national crisis. Of the 575,000 highway bridges across the country, 42% are deficient for either structural or functional reasons. The crisis is brought closer to home when we realize that 80% are rural bridges and nearly half are in need of replacement or rehabilitation. These are the bridges in your towns and in our rural road systems that are the backbone of our infrastructure. Now, an old concept in bridge construction has merged with new concepts in modern bridge design to help ease the current national crisis of bridge deterioration. The old and new concept is timber bridges. Although the traditional New England covered bridge has proven its durability, new technologies for constructing timber bridges pioneered in Ontario in the mid-1970s now offer Vermont and the rest of the country opportunities to improve worsening rural bridge conditions. And they do so cost-effectively with simple and quick construction, immunity to de-icing chemicals, low maintenance, long lifespan, while matching the same load-bearing requirements as concrete and steel bridges. Plus, timber bridges utilize local renewable resources and local labor, thus promoting the local economy.
Good morning. My name is John Stark. I'm with the Department of Public Works in Merrimack, New Hampshire. And I'd like to speak to you about a project, a successful project that we recently completed here in Merrimack, and that was the construction of a covered bridge. And I'd like to start that off with telling you a little bit about how that came to be. In 1988, the Town of Merrimack contracted with a consulting engineering firm to study and rate all of the bridges in the community. As a result of that 1988 study, one particular bridge, the Stoll Road Bridge, was recommended for replacement. Following that recommendation, action took place in 1989, in May of '89, at the town meeting here in New Hampshire and in Merrimack, and monies were appropriated, $75,000 for the replacement of the Stoll Road Bridge. In the early summer of 1990, the town, in receipt of a design for a modern concrete and steel structure, went to bid, and the results of those bids were a construction cost of approximately $100,000. As you can see, those costs were prohibited, keeping in mind that only a $75,000 appropriation had taken place in 1989. Consequently, an alternative had to be found. Upon examining whether or not a timber alternative was in fact cost effective, we were here in Merrimack pleasantly surprised to find that in fact monies could be saved by going that route. Following a investigation of different companies engaged in timber bridges, a decision was made to contract with the Kren Bridge Company of Bangor, Michigan. In fact, the town contracted for a 32-foot timber bridge that has a clear road width of 16 feet. This particular bridge was in the vicinity, materials for the bridge was in the vicinity of $33,000. This did not include, however, the cost of erecting the bridge or the replacement of the bridge abutments. To bring this project to fruition and to keep it cost effective, it was determined that we would, in fact, erect a bridge using force account, i.e. the Merrimack Highway Department would undertake this project internally. To bring this project to fruition and to stay in line with budget constraints, the actual construction of the bridge was undertaken by members of the town highway department. This allowed the town to not have direct labor and equipment charges applied against the replacement bridge fund. With this in mind, construction began. Equipment, material, and people used were as follows. The town has in its equipment arsenal a Cruisair Draught 40 excavator, which was used primarily to excavate for new bridge piers and footings. In this particular view, you see the existing and original Stoll Road Bridge and the exposed excavated stone footings. This excavation had to take place very carefully so that we did not disturb these old footings, primarily because they were laid up dry. Here we have the beginning of the footing with the reinforcing steel being tied on chairs, and you can see our handiwork with building homemade plywood forms with the frame being rough cut lumber. All of the steel was in fact tied to the chairs. The steel work progressed rather rapidly, but attention to detail, of course, was the watchword. Here you see the steel is tied into the existing stone foundations, and with that, marrying the two old and new systems together as the concrete placement commenced. The concrete placement was facilitated by using vibrators, and this work was again cautiously undertaken so as not to blow out the forms or to rupture the existing stone masonry, which acted as one of the forms. As you can see, is we only had to form 3 sides. This footage, the initial placement is almost done, and we're coming out of the ground here, whereas before we were probably in the beginning about 7 feet in the ground after the first placement. We were in the vicinity of maybe 3 or 4 feet. Some more of the steel work and the finishing. In this particular footage, the old bridge has now been taken apart and removed from the site. And you see the old and the new footings and piers in place. Here we have material arriving at the site and the hardware being placed where it would be readily available. At the beginning of the erector set. Here we are unloading the tractor-trailer flatbed with particular bridge members by using the 20-ton truck crane. Because we wanted to preserve the aesthetics in the area, a more difficult pick or lift was the order of the day. Is fortunately the crane operator was pretty accomplished, and this material was swung over some of the existing trees and placed adjacent to the new piers in a field. As I recall, this sorting of material probably took a good hour and a half to 2 hours on the first day of actual construction with the timber members. More sorting of the various members adjacent to where we'll be working. This particular footage shows the bridge cap being lowered into place on the top of the new piers. This of course is rather critical that the two caps are placed as near as possible to the design. The closer that this work is to the design plan, of course, the rest will fall right into place, which you'll see in later footage. And here we are fastening with these quick fasteners into the concrete, the bridge cap, where the rest of the bridge, the three deck pieces, will fasten to this cap. We had portable generators on site so that we would have electricity. There was no electricity right on the site. Here's the fastener going into place. And you'll see that this ties the first timber into the concrete work. These quick fasteners will expand when a wrench is put on them, and they expand into the concrete, causing the timber and the concrete to be married together. Here we have our first panel, or bridge deck. There was 3 on this particular job, being picked off of the flatbed trailer and very carefully picked up over the existing trees and lowered down into place. As the bridge comes into place, we, of course, guided it down and positioned it on these caps. In the foreground, you'll see some telephone poles, which we used just on a temporary basis to allow us to walk back and forth across the brook. Here's the second panel being lowered into place. Each panel is joined with galvanized bolts, long bolts, which are fastened both top and bottom of the panels. Here we have a gentleman underneath the bridge is tightening up a bolt. In addition to the bolts, there are also these large pins where the shiplapped edges of the panels are joined by use of these pins and bolts. Here the deck is again being married into the bridge cap. A lot of heavy labor is now taking place, putting these pins in through the sections. A lot of drilling, a lot of sledgehammer work, putting those pins in place.
Now last, the third panel. This is towards the end of the first day. This particular footage here is shows the last panel going into place, and you can see the shiplap edge. We actually got the bridge even tighter than what is shown, these panels married together by using come-alongs, which I think you'll see in the, here we go with the come-alongs. This is to ensure that everything is just as tightly put together as possible. On the second day, we're now up on top of the new bridge deck. We did that by filling in one side with gravel and stone and drove the town's excavator up on top. The next order of business was building the forms for the second placement of concrete, where this next placement utilizes the new bridge as one side of the concrete form. Here, I believe, is what you're witnessing is the drilling for the placement of the scuppers. Here we have the superstructure partially in place. This is approximately 4 days into construction. We have some of the vertical members now attached to the bridge deck. In this particular footage, the interior guardrail sections are being installed. And again, more heavy work with the sledgehammers and pins. The guardrail system is a 10-kip guardrail system. We were quite impressed with the massiveness of the Western lumber. This particular footage shows the installation of some of the purlins on the roof trusses. The trusses were part of the kit, pre-manufactured. And this footage here is we've taken some liberties with the kit and are installing fire breaks. This will facilitate not only stopping a potential fire on the bridge using native lumber, but also to be a nailing surface for the interior sheeting. It's another shot of the pre-manufactured roof trusses. Again, is the extensive work on these fire breaks on the interior of the bridge. This was hemlock 2x6s that were later sprayed with a fire-resistant material. Here the exterior sheeting begins with the fastening on of the plywood. with the plywood in place. The next is the ornamental sheeting, which in this instance was native New Hampshire white pine. This white pine had been previously stained at the highway garage facility and sprayed with this fire-resistant material. With the ornamental sheeting in place on the exterior and interior of the bridge, the roofing began using hand-split cedar shingles. This took quite a bit of time as we only allowed approximately a 5-inch reveal to the weather. And here is the final product. The approaches to the bridge, by this time, I believe this shot was taken about December 6th, and the ground had frozen. And the approaches, as far as grading, will have to wait now until the next spring. About December 14th, the town fathers, duly impressed with the construction, had a dedication ceremony where the men of the Highway Division were recognized.
We're real busy right now, as usual. The amount of work we do used to really get to me. I was getting farther behind all the time. I'm sure you know what I mean. Then I discovered the Rural Technical Assistance Program. Our county executive gave me the number of the Technology Transfer Center nearest to us. I made the call, it reduced my workload, and has changed my life for the better. It'll do the same for you. Throughout most of the United States, the Rural Technical Assistance Program is a call away. Technology Transfer, or T-Square centers located nationwide, provide an interlocking network of support for people or agencies who are involved with local roads, bridges, and public transportation programs. Along with the Federal Highway Administration, state transportation departments, and selected universities, LTAP's T-Square centers help you work smarter by providing sound advice and information through workshops, printed materials, videotapes, hands-on training, and referrals. Helping you get more for less is what the program's all about.